Really happy to be here and show some of the alternative workflow on how to design a denture for the TrueDent. Okay, so we are going to use Exocad's single denture demo case. All right, same exact thing as for those of you who have Exocad. All we're going to do is change the restoration type. Now, just fair warning, it is an advanced workflow in my opinion. If you want something more simple, as Adrian mentioned, that if you follow the denture module, the wizard or the software guide will take you through the entire process. If you decide to design it this way, we're going to be jumping in and out of expert mode and so on and so forth in order for us to come up with our final product. However, here are the positives about using this workflow, in my opinion. Number one, you are not limited to the denture module or the denture libraries that are available in the software. So you can use any library that the software offers or any library that you may create yourself in order to create to do this. And because of that, you will be able to take advantage of certain features of the TrueDent, especially the fact that you can see the roots of the teeth show through the base. You can actually design with libraries that have roots, and that's what I'm planning on doing right now. All right, so we are going to modify the order form by changing it from full denture. We are going to select mock-up. Now, the material is not going to matter very much here. You can select, for example, 3D print, just to make it easier on you and make it more logical. The one thing you have to make sure you select is the virtual gingiva design step. Okay, so we'll select that and apply the same selection to everything in the arch. All right, so we'll go ahead and make the modification. We'll save the order form and jump right into the design process.
And just to note, while we wait for this to launch, Daniel did not make connectors between the teeth, and there's a benefit to that because when you print with TrueDent, the teeth don't need to be bonded or assembled into the base, and so you're able to get a very natural look and even make overlapping teeth or diastemos, things like this, because it all prints in one piece.
All right, so the software is going to ask us to use the virtual articulator, and I'll just do a quick demo here. So the virtual articulator works best if you actually have if you have models or you have physically mounted in an adjustable or semi-adjustable articulator. Now, there's some pieces that need to go together. Number one, that you mounted it on the articulator. Number two, that articulator that you use in the physical world exists in Exocad. And number three, that your scanner has the right plates, we'll call them, so that when you scan things, they're actually positioned correctly within the articulator virtually. If you don't have that part of the workflow, you will have to manually mount this in the articulator, and so it'll be an arbitrary position. But putting all of that aside, once it's mounted, you have the freedom here to open bites, and I just selected a number here. You can actually close bites by going into a negative value. You can see the bite closing. So depending on what needs to be done, it can be done. So if you decide to import, say, a pre-op model or a pre-op scan, which would be a scan of their existing denture, you can tell the software here in this button, you can tell it which meshes or what surfaces you want to affect the articulation movements. Mm-hmm. So you'll be able to, paint certain areas to be ignored or paint them back to the regular color in order for them to have an effect on the articulation. Okay, so yes, that can be done. What I was going to say is that you have a lot of different articulators. So please, I can't emphasize this enough, make sure that your articulator exists in this list. If it doesn't, then there's going to be a gap in the process. If you are using an articulator that does not exist, Exocad does offer this new articulator, quote unquote articulator. It's a skull, and when you do the movements, the jaw is the one that moves rather than the upper, which is that's new with this new version of the software. So you can utilize that if you need to, but it'll help you put things into position. Okay, good. So let's go to the next step. When we do the model block out, one of the things that I like to do is move things to a point of view where I can see the majority of those undercuts. Okay, and we have some properties here that are going to be applied to this block out that we're about to do. Number one, the software is going to add an offset of 0.03 millimeters, which means it's going to take these this scan and is going to extrude it by that much. And so the new surface over which we're going to be designing the rest of our case is going to be this model made bigger by 0.03 millimeters. You have smoothing, which is how much of this detail, this rugae, do you want transferred over to the new blocked out surface. Now, 72% is kind of a arbitrary number, but it tends to give me, at least for my liking, enough detail where I'm happy with what it does. And then the considered tool diameter, because we selected 3D printing as our material, the software takes this all the way down to 0.1. So because we're not milling, this is really a moot point. So, but I figure I mentioned.
So we can take that, we can remove that checkbox though, even though it's checked. So
yeah,
okay.
You can remove it altogether, and then it won't be considered at all. Now, for the blockouts, or for the way the software is going to block out those undercuts, we can tell it to put an angle to that blockout if we wanted to, and we can also tell the software we don't want any undercuts to be deeper than 0.1 millimeters from whatever insertion direction we select right now on the software. Okay, so with all that explained, I'm going to change my insertion direction by clicking here, and you can see how I got rid of all those undercuts that were shown there. We'll still have some, but not many, or not very deep ones. And so we can now go to the next step, and now the software will create this new blockout surface I was talking about. And that's it. This blue surface is going to be the surface over which we're going to be creating the rest of our design. Now, with this workflow, we get to choose any library that you may have installed here on the software. So if you purchase the ZRS tooth library, you'll be able to use those. If you purchased libraries from different people, you can utilize those. So, for example, I have access to the Grin design, and the reason why I like this library in particular is that it gives me the following: lots of roots. And so that helps me take advantage of the show through that I'm going to get from the TrueDent in order for me to get a more aesthetic result, if that's what I was looking for. Now, that is one of the limitations of going through the Denture workflow, is that most of the libraries there don't have a lot of root structure. So you won't get that good of an effect. But it is a much more simple workflow. There are some libraries that are that have limitations. And in fact, some of the ZRS libraries will not allow you to export as single units. But if you really, really like the library, if you connect it, then the software will allow you to export the connected structure. But if you want to export them as individual teeth, there are going to be some limitations. Now, I have over 300 libraries installed on my computer, and I can't give you a list of which ones will give you that limitation, which ones have it or not. So it'll be, unfortunately, something you'll discover when you go to save it and it tells you, no, I can't save it. Okay, the other thing I like to do here, just to show, is I can mix and match libraries. So let's say I really, really like these interiors, but I don't like the posteriors, for the sake of demo. So what I can do in the software is, in expert mode, holding control, I can select the posteriors, and then I can tell the software, load custom model teeth, and I'm going to change those posteriors to, say, the alternative library, because say you like that better. And so you can mix and match libraries all you want, which is, again, another benefit of using this workflow. All right, so now we jump back into the software, or back into the workflow, I should say, not the software, back into the wizard workflow. And now we get to do our tooth placement. Now, I really like using the chain mode for this. I think this is the best tool. It is definitely my favorite tool in all of Exocad, and especially for full arches, I think is the best thing since sliced bread. So what I like to do is eliminate these anchor points, and I'm going to focus only on the centrals at this point, and I'm going to place them in the most correct position I can manage. Okay, so from every point of view, more or less where it should be. And then I anchor one of the centrals, and I start playing with the opposite side of the arch. So I'm going to go over here, and I'm going to move using the distal plate. I'm going to click and drag it around until I get the occlusion I'm looking for. Okay, and I'm not worried about this whole entire section here of my setup. I'm just focused on that posterior most molar. And then once I get it in place, I will anchor that distal plate also. And what I've done is create a section between the two anchor points. And now I can play around with the curvature of my teeth. And that way I can fine tune it a little bit better to whatever I'm looking for. Okay. And so once I get it in place, I will switch sides with the central. So I will anchor the one that was unanchored and then anchor the original one and do the same process on this side of the arch. So I'm going to look for that occlusal relationship, get it more or less where it should be, anchor that in place, and then play with the curvature of my arch and get it more or less where it ought to be. By the time you're doing this, if done correctly, your teeth should actually be pretty symmetrical. If not, and it does happen, if not, then what you want to do, the way that I like to say parse it out is I'm trying to make the big changes and make my way down to the details. Okay, so once you get the general position of all the teeth, I always like to go here into advanced, to the advanced tab, and then fine tune the placement. So one of the things that I like to address here is the fact that Exocad with the chain mode creates either pinpoint contacts or sometimes it leaves them open like this. And so I like to address that by using the advanced tab. And then I get to decide whether I want to drag the teeth into one another to create a broader contact or to scale the tooth into the adjacent to create a broader contact. So depending on what I'm looking for, I will use either one of those tools. Typically, however, the canines tend to be smaller than they should be, at least in my opinion. And so I tend to scale that one, but move everything else. Okay, so here we have pretty heavy occlusal contact. So I'm going to pull these out of occlusion a little bit. And then I'll go to the other side of the arch and do the same thing. So I'm just to kind of show you what I would address here, but I'm not going to detail it too much. Okay, so once we have everything in place and we're happy with it, we'll tell the software we'll go to the next step. And here's one of the things that Exocad does with this workflow. It wants to know if you want to save the position of the teeth. I always say yes and check this box so it doesn't ask me constantly. Just in case something happens, I can load the same exact setup as I have it right now. I can load it over without having to do everything that I've done. If, let's say that you put your midline here and then you realize that your midline is off, rather than moving each tooth individually to its new position, Exocad offers this tube option and you can just do this and look for your new midline and be done with it. I will say this, okay? This chain mode does have a flaw, okay? And the flaw is that it always designs with pinpoint contacts or it leaves them open. And so once you leave chain mode, you don't want to come back to chain mode because it'll pull them apart. So just to show here, if I go through the process of moving things, shifting these over to create a broader contact, if I go back to chain mode, if I go back, it'll pull them apart again.
Okay.
And so just make sure that once you leave chain mode, you have no plans of coming back to it, unless you have something major like that, like you completely miss your midline, then you come back and fix it. But just a heads up. Okay, so we'll go to the next step, and here what I've tried to address on this particular step is just the high points mainly. So I will usually either remove them by removing material, or if it's a pretty heavy one like this one, I will take the anatomic controls and pull tooth parts down. Now, sorry, let me show one last thing here on the previous step. One of the reasons why I like to use this workflow rather than the denture module workflow is that it gives me access to, in the advanced tab, it gives me access to this tool here, where I can flatten my tooth shapes as much as I need to, or make them pointier, so I can age the teeth according to what the patient looks like. And so that allows me to create, it just gives me more freedom to have it look the way that I want it to look ultimately. Okay. All right, so let me close these up here real quick, and then we'll move on to the next step. And again, I would address those high points by utilizing different tools here, pulling them out of occlusion or removing material. And usually I do want to leave some contacts, but I want my contacts to be around this color scheme here. So dark blue to barely some visible light blue, nothing green or yellow, orange, or red. So I'll just kind of remove material this way. Also, when you remove material for something like this, you want to do big strokes, because if you do small ones, then you'll just dig a hole into the tooth. But if you do big strokes, then it looks a bit more natural, more even. Okay, so I will do this. I'll just leave it like that. Let's just say things are perfect. Now, then the next thing you want to do is to make adaptations to those roots. Okay, so you can cut them either at 0 millimeters of distance. In reality, it doesn't matter, because since we are going to be manufacturing the base with the teeth together, there's no strength limitations that we need to concern ourselves with. All we want to do is make sure that our roots are not unnecessarily long. So I will just adapt it as 0 in this particular case. I don't want them coming through the model like this. So I just cut it at 0. So if you want a little bit more space, maybe you can say here 0.5 millimeter. And you know what? I'll do that real quick. And that way we just gain 0.5 millimeter of distance there. So that's what the software will do. Now, typically, I will also recommend that you smooth this out, but because of the manufacturing process that we're going to go through, this is not a necessary step. You don't have to smooth this out. Okay. So we'll just leave them as is for the sake of demo and go to the next step. Software will ask if you want to do any occlusal or interproximal adaptations. We're not going to do any of that. We'll just go to the next step where we get to draw the outline of our base. Now, in the for those of you who are familiar with Exocad, what we're trying to design here is a gingiva, right? So typically, for like a 3-unit bridge, when there's a lot of bone loss, you create this extra structure to make the pontic not look too big. But the workaround is you can draw that outline as big as you want it to be. So in this case, I'm going to draw it as big as the base needs to be, and we'll get a gingiva for the entire case that will look like a denture. So that is a workaround. Now, the one thing you do want to make sure is that you increase the base thickness here. Now, the software by default is set to 2 millimeters of thickness, but when Stratasys develops their material configuration file, you will have a larger range here. So you can select the 2.5, which is the suggested thickness by Stratasys. All right, so we'll leave that as is, go to the next step, and now we'll get to freeform that base, well, quote unquote base. Okay, so the first thing I always pay attention to is, let's count the papilla. There's going to be black triangles everywhere. So that is the first thing to address here. We'll have all those spaces. So I'll take the small region and just pull down and close those up. Okay, now be careful where you are clicking and pulling, because if you're too far facial, then notice how the gingiva changes. And because of that, you can change the shape of your tooth. So you want your click to be kind of in the middle of that, yeah, let's call it papilla for lack of a better term right now, and pull those straight down. And that way you just get to pull that area where it should go, rather than part of the facial of the base. Okay, so I'll do that all around the arch. And once that's done, what I like to do is make my teeth transparent. And I like to add material on the lingual of the teeth and bring the base up about halfway up the teeth. And I just do this just because that's the way dentures are, and for stability and uniformity on the lingual surfaces, I like to add this extra material. So I'll just take a second to do that. And the reason why I'm making them transparent to add the material is, if they're not transparent, I can only add material where I'm able to see And because I'm not able to see inside of the tooth, then I have to build this type of ledge out. And I'm trying not to do that. And that's why I'm making the teeth transparent so I can add material in the middle. Okay, once that's done, I make all my teeth opaque again, and I will smooth and flatten all that extra stuff that I just added. Okay, just to make it look a little bit more uniform. We'll get to fine tune that a little bit better in a little bit. Forgot to put this one down all the way. Okay, and then what I like to do here is do my festooning. And the way that I like to do it, I like to use the cylinder tool because it adds a lot more texture. I like to show this usually when I'm teaching courses. If I take the strength all the way up, but the size all the way down, and I just draw a straight line using that versus the default tool, you can see how much more texture there is on the cylinder. And that's what I'm looking for. So I'll take the strength down about halfway, maybe a little bit above it. And then I will outline the cervicals of the teeth. Now, once again, just like I was saying a minute ago about pulling the base down, if you're not careful here, you can actually change the shape of the teeth. So just be aware of that. But what you want to do is outline the cervicals. And yes, you want it to look a bit rough. We're not trying to make this look pretty at the moment. Yeah. So right now I'm removing material from between those roots that I created or vestiges of the roots. Now, as you are removing, trying to achieve a very aesthetic or realistic result, you have to be aware that you are removing material and therefore you're getting away from that 2.5 millimeter thickness. And so Exocad offers this checkbox here that gives you a color code based on how much material you're removing. So I want to take this all the way up to the 2 millimeters. And so if I'm seeing blue and light blue, I'm somewhere between 1.5 and 2. So now this is very thin. So it's not going to be proper for our purposes. But just want to point out that you can use this tool to help you gauge how much material you're removing and how thin things are looking. For the sake of just a design demo, I'll turn that off so we can see the detail that I'm creating here. Once I do the vestiges of the roots and remove some material from in between them to kind of individualize them a little bit, I take the smooth and flatten tool and I'll use the default brush type, take the strength almost all the way down and the size about this much, and just quickly run it over the entire thing I just did. And that's the result I can get. And again, because of the high definition that we can print with, we'll see all these details in our final product, which will make it look a lot more realistic. Okay, so we have that. And so now we have everything that we need. Okay, and here's where the complex or the workaround kicks in. So we have our teeth in place and we have our base in place. And now we just want to make sure that, for example, my base is properly adapted to the model. And right now it's just coming all the way through. So we have to kind of individualize the things that we want to save. So number one, I would, I can right click on the save button, and this is available, I believe, within the last 2 versions of the software. And you can say export tooth models. If you click that, it'll export the STL for each one of these teeth in that position. Okay, so it'll create an STL for us. And so we have them here. All right, then the next thing for me to do is to isolate that base. Okay, so I'm going to hide everything else but the base. And then I'm going to right click on the save button and say export scene to mesh. And I'm going to call it base. So I just exported that structure as an STL. And then the last thing I need to export is this block out model. Okay, because this is the surface I want that base to be adapted to. And all this will make sense in just a second. So once again, I isolated, export scene to mesh, and we'll call it model. Okay. Usually when you export a mesh, and I'll do it again, the software will ask a question. So I'll say model. It'll ask, save visible objects only. You click yes. And sometimes, I don't know what triggers this, to be honest with you. Sometimes it asks, what coordinate system do you want to use to export this? It'll give you two options. The top one says original. We don't care what the second one says. We don't use it. Always say original, so that if you take these STLs to a different software, like what's the name of
GrabCAD.
yeah, when you take it there, everything will be in the same position or relationship one to the other. Okay, so that way you can nest them properly. So always select original. All right, so once we've exported everything that we need, we will right click on the cat icon down here at the bottom, and we'll select Dental CAD app, and it'll launch a new instance of the design software that is not tied to any order form. So in other words, we're bypassing all of this. This is just a blank slate. So what I'm going to do is right click on the background. When you right click on the save button and you export a scene to mesh, it'll automatically open up this cases folder. And that's where things are going to get exported to. Okay, so you can access that by either clicking on the tools and going down here where it says show project in Explorer, or if you go back to the Dental DB, you can click here and it'll open that same exact folder. Okay, so now that we have all that, we will load in as our scan data. Will load in the model, and it should be our block out model. It'll ask if we need an antagonist. The answer should be no, because we already took the antagonist into consideration in our original design. And so now the software, even though it's a blank slate, it still needs some kind of instruction. So it's asking us, what are you going to do? Now we want to make the selection that gives us the most amount of freedom. And in this case, that we will, which tell the software, we'll design a pontic, and it's going to ask us, okay, which tooth number? It doesn't matter. Select anything. And then you click next. And then the software is asking you, well, are you doing anything else? We say, no, I'm finished. Okay, that's all we have to do here. We'll correct this insertion direction, or the scan data orientation, I'm sorry. And that's it. That's all we need to do here. From here on out, we'll work in expert mode. Now, one of the things I want to show, and one of the reasons we do this is when I'm designing, when I'm free-forming my denture base here, I am limited to the number of tools that I can use to do the designing. Okay, in particular, I don't have an option for attachments. Okay, and I just want you to pay attention to that. So the thing is, I have to fool the software into believing that this base is not a virtual gingiva design, is actually a crown design. So if this was a crown, I will have access to all of the tools. And so in this new workflow that we're creating, I'm going to go to tools, and I'm going to import into my case a wax up scan. All right, and I'm going to select that base that we've designed. Now, when you select it to import, the software is going to ask me if the coordinate system is relative to the scan data. We say yes, and that's why we always select that original. And look, it brings it in perfectly aligned to the case as I have it here, right? Same exact thing. Now, the only difference is when I tell the software here, calculate the wax up, I just fool the software into believing that that base is now, let's call it a crown. So if I go to freeforming here, look at all the tools that I have available to make changes to that base. I can add attachments. I can pull little areas in and out, whatever may be necessary. I have access to all those tools, okay? Which are not tools that I have available here in the original workflow. So all I want to do here is adapt the intaglio surface of my base. That's all that's missing. So I'll go here to the free, adapt, do the basal adaptation. The software will take a second and make that calculation. And now I have a perfectly adapted base to my model. And there it is. So now what I have to do is perhaps get rid of this little lip that the software created and maybe touch up some detail here and there. And that's it. That will be the end of my design process for this alternative workflow. Once this is done, I will have to one more time export the STL of this base. So I'm going to leave it isolated. I'm going to right click on save, export scene to mesh, and I'm going to call it base final. And so now I have everything that I need. I have my base that is perfect, properly adapted to the entabler surface. And now just to show, I will bring in as a generic visualization mesh, all of the teeth that we placed. And you'll see them come in the right relationship to the base. And so now I have my base with my teeth going through. There's no pockets here. You can see the meshes are going through one another, which is exactly what we want. And we'll be able to see some of that root flashing through the pink of the base once it's printed. And that'll be the entire process.
Awesome. Daniel, would you mind going back and showing us how to export a monolithic denture if we wanted to do it as a monochromatic tri-end, for example, or somebody wanted a one piece and they were going to use a different technology? So on the other design that you have.
Yeah, so from here, where we were, okay, all we will have to do is just finish the workflow. So I'll click next, and now the very next step is the software calculating what in Exocad is called a wax up. So it'll combine my base to the teeth to create a monolithic structure. And it'll take a few seconds to do that. And then you would have exactly what you're asking for. Also in this process, in this original workflow, when it creates the wax up, it'll also make the intaglio adaptation to whatever the model looks like. And we'll end up with the result that we're looking for. So that's kind of what we'll end up with.
Yeah. So if you were to complete this workflow and not go out into the other CAD app, then this is what you would come up with and wouldn't have that adaptation, just for the audience to know. So now you have several different options on how to design. And just a couple of reminders. So some of the key points that we covered were that you can have connectors, but you don't have to, okay? For a more natural look, you may exclude the connectors. You should have a 0 gap between the base and the teeth structure, but it should output as multiple meshes. So anything that's individual, for example, if you have different individual teeth, you will have the ability to be able to assign different shades to maybe the anteriors versus the posteriors. If you have it all as one bridged tooth structure, you will only be able to do one shade, and that's okay too. And then you need to make sure that there's anything that's touching will print as one piece. So if you want to do different colors, they should be separate STL files. If you want them to be touching, they will print together. If you want them to print together, they should be touching. So a 0 gap. And your base should be a minimum of 2.5 millimeters for the optimum strength. So thank you very much, Daniel.